In this video, I will go over the difference of an exothermic reaction versus an endothermic reaction. Let's start with the exothermic reaction. I drew a graph of the reaction progress of an exothermic reaction. We can see some major indicators that this is an exothermic graph. First, the reactants, the energy of the reactants, is greater than the energy of the products. And how can we tell, if we do an experiment, if an exothermic reaction has occurred? Well, we may see light is produced or heat is produced. So an exothermic reaction occurs when the energy released by forming new bonds is greater than the energy absorbed to break existing bonds. So I'll write that as energy to form bonds is greater than the energy to break bonds. So in an exothermic reaction, we are releasing energy. And this is what the graph looks like for it. And just to clarify, this AE, that is our activation energy. This is the energy needed for a reaction to occur. And this activated complex up here, this is when you've reached the top of the activation energy, when you've reached a state where a reaction can occur. Let's move over to an endothermic reaction. So in an endothermic reaction, the energy of products is greater than the energy of the reactants. This means that energy is absorbed. So energy is absorbed. And if you did a reaction, how could you tell energy is absorbed? Well, the surrounding area might be cooler. And opposed to exothermic reactions, endothermic reactions occur when the energy absorbed to break bonds is greater than the energy released by the formation of bonds. So energy absorbed to break bonds is greater than the energy used to form bonds. Now let's talk about enthalpy. So enthalpy is the total heat of a system, and it is calculated as the change of enthalpy equals the energy of the products minus the energy of the reactants. Now you can see I wrote here that the change of enthalpy of an exothermic reaction is negative. Why? Because the reactants are greater than the products, meaning we'll end up with a negative number. But in the endothermic reaction, there is a positive enthalpy because the reactants are less than the products. So let's just do an example to fully understand this concept. So if I have the change of H equals 100 joules minus 50 joules. So in this example, the product energy is greater than the reactant energy. Well, this is an endothermic reaction. The answer is positive 50 joules. So this is endothermic. Okay? But if our reactants were 50 joules and our products were 100 joules, well, then we get negative 50 joules. So this is exothermic. Okay, the last thing I want to touch on is the effect of a catalyst on these reaction progression graphs. So we know that a catalyst will lower the activation energy needed for a reaction. So what will this look like? The path of the catalyst will look a little bit like this. So we've shortened the distance from the reactants to the products, but what this actually means is we've lowered the activation energy, because the new activation energy is this. We've completely lowered the activation energy, making it easier for a reaction to occur. What does this look like on an endothermic graph? Something like that. So again, we've lowered the activation energy. Okay, let's go over some examples. So in these examples, we're going to determine if this is an endothermic or exothermic reaction. Number 1, energy of reactants is greater than the energy of the products. Well, this is exothermic. Number 2, if you get a positive change in enthalpy, well, that's going to be an endothermic reaction, because the products have higher energy than the reactants. Number 3, energy is absorbed. This is also an endothermic reaction. Fireworks. Fireworks is an example of an exothermic reaction. It's a combustion type reaction where heat and light is produced. Baking a cake. This is an endothermic reaction. Why? Because we have to add heat to cake batter to turn it into a heat. So it's absorbed a lot of heat, making it endothermic. Starting a fire, this is exothermic, because you're producing heat and light. Okay, and then this is just a basic reaction progression graph, and we have to determine if this is the graph for an exothermic or an endothermic. This is endothermic. I hope this video cleared up the difference between an exothermic reaction and an endothermic reaction.